Hello guys, today we'll be looking at what comparison of two population and mean. The situation whereby we have more than one population mean to what? To be compared in hypothesis testing. Now the question says the average blood sugar of a 49 diabetic patient is 142 with a known variance of 144 on the administration of glucovans. Now another set of 64 patients has average blood sugar of 148 with variance of 265 on the administration of glucophage. Now the question says, is there any significant difference between the mean of the sample at 5% level of significance? So we're going to compare these two samples and know whether if there is any significant difference between them at 5% level of significance. Now solution, we have our sample 1, we have glucovans, we have N1, which is the sample size to be 49, our sigma 1 squared, which is the population variance to be 144, and our S bar 1, which is the sample mean of the first sample to be 142. Now we have our sample 2, glucophage, we have N2 to be N2, the sample size of this second sample to be 64, and the population variance to be 265, and the sample mean of the second sample to be 148. So the first step is to what? To state your hypothesis, the null and alternative hypothesis of this particular question. So our H naught will be no significant difference. No significant difference between the samples at 5%. Now our H1, which normally contradicts the H0, we normally say that there is a significant difference between the samples. So our H1 is equals to there is a significant difference between the samples. So this is the first step in performing the hypothesis testing out of the 7 steps. So the second step is what? To choose our level of significance. In the question we have our level of significance alpha to be what? 5%. So our alpha is equal to 5%, which is equivalent to what? 0.05. So our alpha is 0.05. This is the second step. So the third step is what? To choose your test statistics. So in our previous class, I showed you how to choose the appropriate test statistics to use. So in the question we have, I told you that the way to use statistics, first of all, consider whether the sample size is greater than or equal to 30. When the sample size is greater than or equal to 30 and the population mean is given, you will use Z statistics. And if you have our population mean unknown and also we have our sample size to be greater than 30, we can also use Z statistics or Z test. Now, but when the sample size is less than 30, we consider it as a small, so we use the appropriate test statistics to use is a T test. But when we have more than 2 population mean, let's assume we have more than 2 like 3 population mean to be compared, the appropriate test to use is a F test. So in this question, we have our population mean to be population variance given, and the sample size are all greater than what? 30. So we are going to use the Z test. So the third step is what? Our Z test, which is equals to our Z test. So the third step is what? To use our Z test, which is defined as Z, which is equals to x bar 1 minus x bar 2 minus mu 1 minus mu 2 all over square root of sigma squared 1 all over n1 plus sigma squared 2 all over n2, where these x bar 1, x bar 2 are the sample mean of the samples. These mu 1 and mu 2 are the population mean of the samples. Sigma 1 and sigma 2 are the population variance of the samples. And N1 and N2 are the sample sizes of the two samples. Now, in the question, our mu 1 and the mu 2 are not given. So our population mean for the first sample and the second sample are all 0. So this formula now we now reduce to what? Z is equals to x bar 1 minus x bar 2 all over what? The square root of sigma 1 squared all over n1 plus sigma 2 squared all over what? N2. So we have our x bar 1 to be 142. We have our x bar 1 to be 142. So we have 142 minus 148, which is the sample mean of the second sample, all over the square root of the population variance of the first sample is what? 144 all over the sample size, which is 49, plus the population variance of the second sample is 265 all over the sample size 64. Okay, so this will give us 142 minus 148 will give us minus 6, minus this is equal to minus 6 all over 140, the square root of 144 over 49 will give us 144 over 49 will give us 2.94 plus 265 over 64 will give us 4.141. Okay, if you add it up and take the square root, you have that this is equal to minus 6 all over what? Square root of 7.081. 7.081. So this will give us Z is equal to minus 6 all over 2.66, which gives us, implies that Z is equal to minus 2.28. So the third step is to choose the appropriate test statistic to use. So which is what? Our Z. We use our Z because for this question it is the right statistic to use. And the first step is to compute the value of Z, which we have done already, and we have our Z calculated. Our Z calculated will be what? Minus 2.28. So the next step, which is the fifth step, is to what? To choose your decision rule, to define your decision rule. Now, our decision rule in this question says that reject H naught. This is reject H naught. Reject H naught if Z CAC, absolute value of Z CAC, is greater than absolute value of what? Of Z tabulated. So at alpha level of significance, we have what? Our Z tabulated, our Z tab, we got this one from what? Our Z table. So we got this, our Z table. So our Z tab at alpha level of, at alpha equals to 0.05 is equal to what? Z alpha over 2 is equal to what? 1.96. Okay, 1.96. That value is from what? Table of Z table. Okay, so the sum rule says we should reject H naught if absolute value of Z calc is greater than absolute value of Z tabulated. So the next step, which is the final step, is what? To conclude, to draw your conclusion based on the values of the test statistics you have computed. So this will give us a conclusion since Z calc at minus 2.28 less than Z alpha over 2 at minus 1.96, comma, we do not reject since our Z calc at minus 2.28 less than Z alpha over 2 at minus 1.98, we reject the null hypothesis. So which says that there is no difference between the two samples. So we reject the null hypothesis which says that there is no difference between the two samples. So hence we conclude that there is a significant difference between those samples drawn from two diabetic patients. So we do not reject the null hypothesis. We reject the null hypothesis and conclude that there is a significant difference between the samples okay. So that is the end of the class. So our next class will be looking at what? The power function. How to derive the power function, what p-value is, and how to get them. Okay? So if you have any question in this one that we have done today, you can drop it in the comment section so that we can tackle it together. Thank you.